FBH equal to 1.77 kilonewton. Okay. Next, our second equilibrium equation. Applying that, we will consider the forces of this figure FBC, FBA, and FBH. So FBC, 5.77 is the value of okay, 5.75 is the value of FGH, FBC, then FBA, we already have this value, FAB. So from this value of these forces we can put 5.77. Okay. This is from force FBA, and 1.77 we will get this value from FBH cos 45, because we have to consider the horizontal forces for FBH, so we put cos 45. And after calculating this value, the member of BC forces will be 7 kilonewton. Do you have any question? Okay, I'm going for the next part of this solution. Now we will consider the joint K. Okay. From this side we consider joint F, joint A, joint B, and joint G. From this side now we will consider joint K. Just draw the free body diagram for K. FKE, and this is 6.25 kilonewton force which is applied directly. This one 6.25 kilonewton. Is that okay? And the forces FKJ of KJ. So from this joint K, if we consider the equilibrium equation function of x equal to 0, we have to consider only one force of horizontal equation for FKJ, this force, and which will be equilibrium equation equal to 0. So the value of KJ will be 0. And next, if we consider the vertical forces function of y equal to 0, in that case we have to consider the force FKE and the direct force 6.25 kilonewton. So after calculating FKE will be 6.15. Okay, it would be 6.25. This would be 6.25. Okay. Next, we will consider joint E. In this joint, if we draw the free body diagram of joint E, we will find this figure FKF, FKE, and force FJE, and the horizontal force FDE. Just apply the equilibrium equation here. Function of y equal to 0. In that case, we will consider only FKE value, and we already know that the value of FKE equal to 6.25 from this equation. And now calculate the vertical forces of JE. FJE cos 45 minus 6.25. After calculating that, we will find the value of FJE value. Next, applying the equilibrium equation for function of x equal to 0, we have to consider only forces of the member DF and the horizontal forces of member JE. In that case, we will get FDE minus 8.84, that means FEJ cos 45. This is for horizontal component of the forces FJE. After calculating that, after we got the value of forces FED 6.25. In our next step, we have to consider joint J and joint D. In case of joint J, the free body diagram will be this point is J, this is for FJK, this is for FJE, FJD, and this is horizontal force for FJH. In this case, if we consider the equilibrium equation for the vertical forces, we have to take the forces FJD and the forces for FJE, vertical component of the forces of FJE. We already know the value of FJE from our previous equation, from our this equation 8.84. Okay. Just put the value of FJE and calculate this for FJD. The result will be 6.25 for FJD. Next, we have to apply the equilibrium equation for function of x for this free body diagram. FJH minus, in this case we have to consider FJH, FJK and FJE, the horizontal component of force FJE. So we can go for in this case FJK equal to 0 from our previous equation. FJK equal to 0, just put this value and put the value for FJE. After that, calculate the value for FJH, which will be 6.25 kilonewton. Now at last we have to consider point D. In this joint, if we apply the equilibrium equation, this is point D, this is 3 kilonewton directly applied to D, and this is for FDE, this is for FDJ, this is for FDC, and another force is working FDH. Okay. If we apply the equilibrium equation to vertical forces, we have to consider only 3 kilonewton FDJ and FDH. We know the value of FDJ already from this equation. We will calculate FDH. First we consider the vertical component of FDH cos 45 FDJ plus 3 kilonewton, which is directly applied. After that we will got the results FDH equal to 4.6 kilonewton. Now we are applying equilibrium equation for horizontal forces, where we have to consider FDC, FDE and FDH. From this equation we have to calculate FDC. We already have the value of FDH and FDE, so after putting this value we will get the value of FDC. So after considering most of the joints, we already get all the values of the members of this truss. We already got all the values. This is end of our first problem. So do you have any question to follow me? Yes. Please. So any other question, please?
Where did we find out CH?
DH?
Yeah.
Okay. Just consider the joint D. First draw the free body diagram of D. See this figure for D. In this figure apply 3 kilonewton directly, and the forces for FDE, this one, and the forces for FDC, this one, the vertical forces FDJ and these member forces DH. Apply the equilibrium equation for this free body diagram, function of y equal to 0. In case of vertical forces, you have to consider this 3 kilonewton FDJ and FDH. We put the value FDH cos 45 because we will consider only the vertical component of FDH. So after putting this value, and we already have the value of FDJ, just put the value in this equation and you will get the value of FDH. Is that okay now?
What about CH in the middle?
CH, okay. If we consider now, you already know this value of BC, CD and 3 kilonewton. If you consider the joint 3, you can do it by you. Just consider joint C. I am drawing here. Three kilonewton and FCD, FBC and FCH. Okay. In this diagram, you have to find out the value of FCH. Just consider function of y for this diagram equal to 0. You will get FCH equal to 3 kilonewton. Is that okay now?
Yes, that's fine. Thank you.
Okay. Any other question for this problem? Okay.